Hello my dear friends, I am Shubham from LearnoHub, the free learning platform where you can study physics, chemistry, maths, biology absolutely for free at learnohub.com. So then, let's start. So friends, in this video we are continuing the second part of your basics of organic chemistry. Okay, in the previous part we have studied the half of the basics. Now in this video we are going to continue from that half and we would complete all the basics, and then we can move ahead on to the alkenes and alkynes part. Okay, but yes, at the end of this video we are going to discuss some questions which have been asked in your previous year exams based on whatever we have studied so far, the basics of organic chemistry so far. Okay, so without wasting much time, let's start and let's rock. Okay, so let me give you a disclaimer before starting to watch this video. Right from this point, I need to tell you one thing, that you need to watch the previous video, okay, because it was the first video of the basics of the organic chemistry. Until and unless you go through that video, if you don't understand all those things, there is no use of watching this video right now, because I have divided the topic of basics into this subtopics, and out of these subtopics, we have covered up the introduction to organic compounds. We have seen the basics of structural formula, how to write the structural formula, very basic idea. And yes, a very prolonged discussion and important discussion on the nomenclature along with the IUPAC nomenclature. Okay, and in this IUPAC nomenclature, we have started with this first, how to write the name by looking at the structure of the organic compound. And for that, we have studied the rules in the previous video. Now, in this video, we are going to start with we are going to actually practice, or we are going to actually make use of those rules and practice some organic compounds, okay, specific organic compounds which you should know how to name them according to your syllabus. Okay, so after that we are going to see homologous series and isomerism in this video, and then we would solve some questions and we are done with the basics. Okay friends, so let's start to understand the rules which we have studied in the previous video for IUPAC nomenclature, and how we are going to understand them by taking one example of the alkane, alkene, alkyne, alcohols, aldehydes, carboxylic acids, alkyl halides. Okay, so that you would get a clear idea how to name all these organic compounds. Okay, a basic idea you would get, and then after that you need to practice more and more examples or more compounds like this, so that you would get a hold on it. Okay, so now first, in order to understand the rules, let's start with the simplest organic compounds, which are open chain hydrocarbons, right? Open chain hydrocarbons, saturated and unsaturated hydrocarbons. We have studied saturated are alkanes, unsaturated are alkenes and alkynes. So first one, okay, this is the organic compound. Now we have to write the name of this organic compound, right? Now what is the first rule? Longest carbon chain we have to select. Now this, you can observe here, this is the longest carbon chain itself, right? No other alternative chain is there, or we cannot find any other alternative chain. Okay, so this is the longest carbon chain. Now we need to take care of one thing, that the functional group should be the part of the longest carbon chain, but here there is no functional group, right? So no need to worry about that. Then the second rule is numbering of the carbon atoms, right, in the carbon chain. So that also rule we would follow by keeping one thing in mind, that the alkyl groups and the functional group must be given the lowest possible number. But here there are no alkyl groups, no functional groups, right? So just we can simply number it in the way we want. Okay, we can start from here, we can start from this side, we can start from that side. Okay, nothing matters. So now, starting from, I would start numbering the carbon atoms from this side. So 1, 2, 3, 4, 5 and 6. So what we come to know when we number the carbon atoms is that in our longest carbon chain, how many carbon atoms are there, and the number of carbon atoms in the longest carbon chain, okay, number of carbon atoms in the longest carbon chain, okay, will tell us the root word, okay, of our organic compound. So our first job is to find the root word. Okay, it's the very easy part. So now here also we are, after following the first two rules, the selection of longest carbon chain and the numbering of carbon chain, we would find out the root word. So root word, we can find out by knowing the number of carbon atoms in the longest carbon chain, which is now 6 in this case. So root word for 6 number of carbon atoms is hex, right? Try to remember, we have studied it already in the previous video. Okay, so I would just write simply hex then as the root word. Now try to remember, I have told you that organic compounds name consists of 3 parts: prefix, root word and suffix, right? prefix comes first, then root word, and then we write the suffix. So I have jumped directly on the root word, and you also do the same thing. Always jump to the root word first because it's simple to know. After that, okay, so after that, once we write the root word, then we need to see whether the compound is having carbon-carbon single bond, carbon-carbon double bond, or carbon-carbon triple bond. So now here in this compound there is carbon-carbon single bond, correct? So what I would do, we know compounds having carbon-carbon single bond, alkane, then the suffix for alkane is ane. So we got the suffix as well. Okay, so in this way we would reach to the suffix. So I would write suffix ane. Okay, now remaining part is the prefix one, but for prefix I have told you the prefix is related to either the presence of alkyl groups or halide groups, but here there are no alkyl groups, no halide groups, so no need of the prefix. So that's it. Our root word and suffix makes the name of our organic compound, which is hexane. Okay, it's simply alkane. Okay, 6 carbon alkane. Clear? Now moving ahead to the next example. Now same logic we will follow. This is the longest carbon chain, right? 1, 2, 3, 4, the only chain. Now I don't need to explain this more again and again because I hope you now know how to find out the longest carbon chain. Okay, now and in case of in the simple cases, it's like obvious. You can see that it is the only chain, so it is the longest carbon chain. Now here we have made sure here in the longest carbon chain the functional group is also present, so that's it. Numbering of carbon chain. Okay, from now here you need to take care of one thing, that how to number the carbon chain then. Okay, because we need to keep track of one thing, that is the functional group or the alkyl group must get the lowest possible number. So if I would start numbering the carbon chain from this side, okay, so 1, 2, 3, 4, okay, then our double bond, here you need to remember or you need to understand one thing. Okay, here the double bond is between the second and the third carbon atom. Okay, when I start numbering from here. When I start numbering from here, the double bond comes with, see, 1, 2, 3, 4. Again, the double bond is between second and third carbon atom. Okay, so now in such scenarios, the position of the double bond, okay, is taken such that the double bond is, or the triple bond, okay, or the triple bond as well, if it is between the 2 carbon atoms, and those 2 carbon atoms we have numbered. Okay, now in both the cases the numbering, okay, if I start numbering from this side or this side, the numbers are same. Okay, so I can number from any side. Okay, first of all. Secondly, now what would be the position for the double bond? Okay, because it is a functional group, right? I have told you that double bond and triple bonds are also considered as functional group. They are considered as functional group, but they do not fit into the definition of functional group. Okay, but yes, since they are functional group now, so what we need to do is, okay, we need to specify the position of the functional group, because it can be present between this carbon and this carbon, this carbon and this carbon, and this carbon and this carbon. So where it is present exactly, we should come to know from the name. Okay, here there was no such scenario because we know all carbon atoms are having single bonds, but here there is one carbon atom which is having double bond, so we need to know where the double bond exactly is lying, between which 2 carbon atoms. So for that, now we can figure out that between second and third carbon atom it is lying, but we consider the position of the double bond as the lowest carbon atom number. Okay, so I will always, okay, in this scenario I will take that the double bond's position is 2. Okay, done with this, the longest carbon chain, the numbering part, and the position of the double bond. Here now we would again go with the root word first. Okay, so root word, what it would be, 1, 2, 3, 4, 1, 2, 3, 4. So 4 carbon atom root word is meth, eth, prop, bute, right? So bute. Now I know there is a double bond. Okay, one double bond between 2 carbon atoms. Okay, though there are single bonds, but there is one double bond between 2 carbon atoms, and when there is at least one double bond between 2 carbon atoms, then we know that that compound is alkene, right? Okay, that open chain hydrocarbon is an alkene. So for alkene, what is the suffix? It is ene, correct? But again, the double bond where it is lying, we need to denote that double bond's position. So for that, what we do, after this root word, okay, and before writing the suffix ene, what we do is we denote the position of the double bond, and we have already found out the position. It is 2, right? Because it is between second and third carbon atom, and we always take the carbon atom number which is lower. So 2. So position of the double bond is 2. And whenever we write the number, I have told you, between the words we keep the hyphen between the number and the words. Okay, so number and the word hyphen, number and the word hyphen. So the name is bute 2ene. Okay, clear with this part? Now in the same way you need to name this third one. Okay, so you try on your own to name this. Okay, you pause it here. So I hope you would have tried, and yes, this was also asked in your exams in 2019. Okay, it's very simple. You have to apply the same logic as that of the previous one. Here also, again, the longest chain. This is the longest chain. As simple as that. 1, 2, 3. Okay, simply the chains are the carbon chain. Okay, you can see here it is very straight. Simple carbon chain, only carbon chain. So longest carbon chain, and then numbering it is the second task, by keeping in the mind that functional group should get the lowest possible number. So I can number from this side 1, 2, 3. I also can number from this side. Okay, 1, 2, and 3. But when I start numbering from this side, okay, the triple bond is between first and the second carbon atom. And when I start numbering from this side, okay, the triple bond is between second and the third carbon atom. So which one I would prefer? First of all, this numbering I would prefer, because our triple bond is between the lower numbered carbon atoms. Okay, so this is right, this is wrong. Okay, so I would just rub it. This is the correct numbering then. Now in this, we know that the position of the triple bond we need to denote in the name. So here, out of these two carbon atoms, the carbon atom which is having lower number, that is the position. So carbon atom 1 is lower, right, in the number. So carbon atom 1, so 1 is the position of the triple bond, correct? So now I would write the root word first. So root word 1, 2, 3. 3 carbon atoms in the longest carbon chain. So meth, eth, prop. Prop is the root word. And then, okay, I know this is also having a single bond, but it is having one triple bond. Okay, so one carbon-carbon triple bond, at least one carbon-carbon triple bond, then it is an alkyne, correct? It's simply a hydrocarbon. Okay, a very simple hydrocarbon, not a derivative. So simply alkyne is there, right? Clear? Now here, so how you would figure out whether it is alkane, alkene, or alkyne? You can just look at the structure. You would figure out. Okay, since it is open chain, first of all, then it is a saturated one, it is an unsaturated one, okay, because it is having triple bond in it, and it is made up of only carbon and hydrogen. So open chain, unsaturated hydrocarbon having triple bond. Okay, open chain, unsaturated hydrocarbon, okay, having carbon-carbon triple bond. So can you just recollect how we have studied the classification? Okay, open chain hydrocarbons, closed chain hydrocarbons, and in open chain there were saturated, unsaturated, and in unsaturated there were two alkenes, alkynes. The alkynes were those who were having carbon-carbon triple bond. So yes, now you can just reach to the point that yes, okay, this is a alkyne then. Okay, because it is an open chain compound. Okay, open chain hydrocarbon, okay, made up of only carbon and hydrogen. Then in the open chain hydrocarbon it is unsaturated, okay, because it is having a carbon-carbon triple bond. And then which unsaturated hydrocarbon it is out of the alkene and alkyne, it is alkyne. Okay, so you can just reach to this point, figuring out that this is an alkyne, and then the suffix yne you can use. Okay, but again the same thing, we need to denote the position of the triple bond, right? And what we do is we just denote it before the suffix and after the root word by just putting a hyphen in between them. Okay, so here the position is first carbon, correct, right? So I would just write here 1, because we have already seen why 1 is the position of the triple bond. Okay, the lowest number out of this 2 carbon atom is 1, that's why. So our answer would be, or our compound's name would be prop 1 yne. Now let's see an example of an alcohol, how to name an alcohol. So this is the example. Now here first we would find the longest carbon chain. This is the longest carbon chain, you can figure out, right? Okay, then numbering of the carbon chain, and yes, while selecting the longest carbon chain we have ensured that our functional group is also the part of the longest carbon chain. Second, numbering of the carbon chain in this way that the functional group gets the lowest possible number. So from this side 1, 2, 3, 4, our functional group is attached to the 4th carbon atom, okay, from this side. And from this side 1, 2, 3, our functional group is attached to the 3rd carbon atom. So which one you would follow? The numbering which is giving the lower number to the carbon atom to which the functional group is attached. So from this side, okay. So 1, 2, 3, 4, 5, 6, we have numbered it. Before moving to the root word, okay, we need to see the position of the functional group. So functional group is attached to the 3rd carbon atom, so the position of the functional group is 3, right? Now we will move to the root word. So 6 carbon atoms, root word is hex. Simply carbon-carbon single bonds are present here, okay, but there is a functional group, right? So this is not a this is not purely an hydrocarbon, but since it is having carbon-carbon single bond, then this means that it is having alkane-like structure, right? So it is a derivative of an alkane simply. So that's why we use the suffix a and e then. Okay, root word is done, suffix is done. But now remember the fifth rule, which was whenever we are having functional group, okay, so what is done here in the place of e, okay, in the a and e suffix, okay, here in the place of e, what we do is we denote the position and the suffix of functional group. Okay, so I would just do the same. Then I would just replace the e with the position and the function of the position and the suffix of the functional group. Now here first we need to denote the position. Position is denoted by the number, and here the position of the functional group is 3 because our functional group is attached to the third carbon atom, right? So position is 3, right? Then the suffix of the functional group is OH, alcohol group, right? Hydroxyl group. So this, okay, not hydroxyl, but you just remember alcohol group. A single name for the functional group, if you would remember, it's also fine. So this alcohol group suffix is OL, okay? So I would just write OL, alcohol. I have told you to remember this, alcohol, then last OL, okay? Aldehydes first AL. So this is position, this is the suffix, and our answer is done. Okay, this is the name of the compound. Clear? Let's see the next example of aldehyde. So here also same way, I have taken a very simple example. So longest carbon chain CC, okay, 2 carbon atoms simply, and here we can see that this C double bond OH group is present, right? And this CHO group is called as an aldehyde group, right? But still we consider the carbon atom here, okay, in the chain. So what we would do is, this is the longest carbon chain, then simply by taking care of that the functional group is a part of the longest carbon chain, then numbering is done in such a way that the functional group is getting lowest possible number. So this carbon atom itself is a part of a functional group, but yes, it should get, we need to make sure that it should get the lowest possible number. So if I would start from here, so it would be 1 and then 2, right? But it is getting 2 when we start from here, okay? But if I would start from here, it would get 1 and then 2. So our carbon of the functional group itself, okay, is getting the lowest possible number, correct? Okay, or our functional group, okay, now here in this case, see, this is a functional group, this is attached to this carbon atom, but we consider this carbon as well. That's why we are giving this carbon the lowest possible number, okay? So in short, we are giving the functional group the lowest possible number. Clear? In case of OH, alcohol group, okay, what we have did is we have given the carbon to which the OH group is attached the lowest possible number. In this case, we have given the carbon of the functional group itself the lowest possible number. So you just keep one thing in mind, the functional group must get lowest possible number, okay? Though if it is like aldehyde functional group, so the carbon atom of the functional group must get lowest possible number. If it is like alcohol functional group, so the carbon atom to which the functional group is attached should get the lowest possible number. Okay, now here this numbering is correct. Okay, now what I would do is, next is would erase this so you won't get confused, and there is no scenario of the prefix here. Okay, in the previous example also there was no scenario of prefix, right? Because there was no alkyl group or halide group, so I haven't taken the prefix here. Okay, just the root word and the suffix part, and that's all. So here also the same scenario, there is no scenario of prefix here. Okay, just simply the root word and the suffix would do our job then. So root word is 1 2, which means meth and eth. Okay, and then carbon carbon single bonds, so A and E. And yes, we know that now there is a functional group, so we would replace this E with the position and the suffix of the functional group. Okay, E with the position and the suffix. Okay, so position is like 1 here, okay, of the carbon. So position is 1. You can see here the carbon of the functional group's position is 1. So 1, and then suffix of the functional group, aldehyde's functional group suffix is Al. Okay, so Al, so ethan 1 Al. Okay, this is the name. Okay, now let's see the example for the carboxylic acid. So this is the compound. Then now same like the aldehyde group, okay, here also there is a carboxyl group, see COOH group. okay, functional group is present. So so starting from the longest carbon chain, okay, choosing the longest carbon chain, we would include this carbon as well. Same for like aldehyde, okay, I have told you we include the carbon of the functional group as well in the longest carbon chain. Here also we would include the carbon of the functional group in the longest carbon chain, okay, carbon of the functional group in the longest carbon chain. And we would secondly number it in such a way that the carbon of the functional group gets the lowest possible number, correct? If the functional group is having carbon, then what we do is same like aldehydes, the carbon of the functional group must get the lowest possible number, okay? So here this must get the lowest possible number. So if I would start from here 1 2 3 4, it would get 4 number. If I would start from here itself, it would get 1. So I would just number it from here 1 2 3 4. Okay, clear with this part? Now we know the longest carbon chain, we have numbered it, we know the functional group's position as well. Then what's remaining? The prefix part. So prefix, there is no prefix here, okay, no alkyl group, no halide group. So simply we just skip the prefix, jump to the root word then first of all. So root word is 1 2 3 4, then meth eth prop but, okay, meth eth prop but, and then after that carbon carbon single bonds, so A and E, and we know that functional group is there, so we just replace the E. Okay, you just follow the same method which I am following. It would make your job easy, okay, make your work easy of writing the names of the compound. Okay, though you write the A and E first entirely, you write it with a pencil in your paper in your exams also, then you just erase it, then you write the final name, okay, by writing the name, temporary name with the pencil, and then erase it and then write the final name with the pen. So but A and E, so E is replaced by the position and the suffix of the functional group. So position is 1 dash 1 dash, okay, number is separated from the words by hyphen, okay, groups by hyphen, and then the suffix for the COOH group, carboxylic group, is oic acid, okay, oic acid, this. So I would just write here oic acid, okay, so this is the name of the compound, butane 1 oic acid. Now let's see the example for alkyl halides. Actually this compound you no need to study because it's not there in the syllabus, okay. Actually there is no need to study the nomenclature of this compound because it's not there in your, it's not written in the syllabus. But why I'm teaching you this is because when we would study the next topics, alkane, alkene, alkyne, so at that time we would use this, okay, use the method of naming the alkyl halides, okay, that's very important. So that's the reason we are learning it here. So it's very simple, same, very easy, but just there is a one change, okay. What we do is for the functional groups we just include the whatever part of the functional group is there for the suffix, but here when the halide is the functional group, it becomes we always denote the halides as prefix, okay. And how we denote it? Okay, if the chlorine atom, okay, if chloride means if chlorine is there, okay, then we write chloro, okay, the prefix. If bromine is there, we write bromo. If iodine is there, we write iodo, okay. And yes, starting fluorine is there, then we write fluoro, okay. So these are the names which we write as the prefixes before the root word, okay, if our halide functional group is present. You need to remember this thing. Now again the same rules. So longest carbon chain including a functional group, numbering on the carbon chain such that the functional group gets the lowest possible number. So I would just number it from this side, okay, because if I would number from this side 1 2 3 4, it would get 4, okay. The carbon atom to which the bromine is attached, it would be 4, and if I would start from this side, the carbon atom to which the bromine is attached, it is 1, right? So I would just prefer this 1 because lowest number is given, right? Then that's it. We would just jump on to the, we know now the position of the functional group as well, so we would jump on to the root word. So 4 carbon atoms, but, okay, meth eth prop but, and then single carbon carbon single bonds, so A and E, and then we know that the functional group is there, right? So here we won't replace the E, okay. What we would do is simply, which functional group is there here? Halide functional group is there, right? So what we would do, we would write the halide functional group as the prefix, okay. So this is the root word, this is the suffix, and then the prefix would be, okay, I'll just make it small, the prefix would be bromo, right? Because it is the bromine halide, bromine atom, so bromo, okay. And now when you write the prefix, you need to also, okay, when you're writing bromo, chloro, iodo or fluoro, you need to also show its position. Okay, write its position as well. So position is written initial before the bromo-chloro-iodo-fluoro word. Okay, so here it is attached to the first carbon atom, so position is 1. So 1-bromobutane. This would be the correct answer. Okay, this would be the correct name. Clear? In this way, you have to write the names of the alkyl halides. Okay, so now let's see the branch chain examples. So that you would get an idea how to write the prefix along with the root word and suffix, because we have seen a lot of examples, okay, where we have studied how to write the prefixes, but entirely how to write the prefix along with the root word and suffix you would get to know from these two examples. Okay, a basic examples. So you can see here, this is the first example. The longest carbon chain is this one, because see 1 2 3 4 5 6 carbon atoms are there. Okay, 1 2 3 4 5 carbon atoms, so this is the longest carbon chain then. And yes, then we would number it in such a way that the alkyl group or the functional group gets lowest possible number. So when I would start numbering from here, okay, it would be 1 2 and 3. So alkyl group is attached to the third carbon atom. Okay, if I would start numbering from here, it is 1 2 3 and then 4. So alkyl group is attached to the fourth carbon atom. So lowest number is this one, right? So I would just number it from this side. Okay, this is the incorrect one. Okay, so yes, I have erased it. Now moving ahead, simply we need to write the root word then. Okay, so 6 carbon atoms, right? 4 5 6 3 4 5 6. So 6 carbon atoms, root word is hex. Carbon single bonds, so suffix would be A and E, right? So root word and suffix is done. We know there is no functional groups, that's why I have written simply A and E. Then the alkyl group is there, right? And here whenever the alkyl group is present, okay, in our longest carbon chain, we just write its name as a prefix. We have studied. And how we write the name as a prefix? Okay, by showing the position before writing the name. Okay, so how the name is written? Methyl. Okay, and the position is written before the name. So third, it is attached to the third carbon atom, therefore 3-methyl. Okay, so this I would just keep, and this I would take and I would just join to this one. Okay, the prefix and the root word and suffix would just get attached. So what I would get is 3-methyl hexane. Okay, clear? No need to give the space between the name. Okay, methyl and hexane you can just write in one go. Okay, no need to leave a space here. Clear? I have told you earlier this thing. Now moving to this one. So this is an interesting one. You can have a look. You can try on your own. If you would write the right name, then it's well done. You have understood the rules well. If you are not able to write the right name, then it's like you are learning it. So no need to worry if you are getting wrong. We will learn, right? Because why we come here? We come to learn, right? So there should be no fear of making the things wrong. It's fine. Just you should remember one thing, that once you get wrong, you should correct yourself. Okay, that's very much important. Okay, because it's a human nature to get wrong, but human nature is also to correct those things. Okay, not to make the same mistakes again. So coming back to the chemistry, leaving the philosophy behind. So here now I would again take the longest carbon chain. So here 1 2 3, this can also be the chain, see, and 1 2 3, this can also be our longest carbon chain. But we need to remember the second rule, right, which is we should include the functional group in our longest carbon chain. That means the functional group must be directly connected to the longest carbon chain. Okay, now if I would consider this chain CH3 CH CH3, our functional group is not connected directly to the chain, because our chain is this. Okay, functional group is connected to the CH2 group, and then the CH2 group is connected to this CH group. Okay, so it is not directly connected. But if I would take this chain, see, our carbon is directly attached to the functional group. Okay, the chain carbon, okay, the carbon in the chain itself is directly attached to the functional group, and we want this thing. That's the meaning of the line which I have told you earlier, that the functional group must be the part of the longest carbon chain. Okay, so this is not the correct chain. I would discard it. Okay, right? So functional group must be directly attached to the carbon of our longest carbon chain. Now here I would number it. So I would number it from here only, because if I would start numbering from this carbon 1, 2, 3, our functional group would get third number. Okay, means the carbon would get third number to which the functional group is attached. Now what I need to do is I need to start numbering from this one, because it is now getting a lower number, right? So this is the right way of numbering. This is not wrong, right? Not right. Okay, incorrect way. Now moving ahead, we know that the alkyl group is also there, so there is some prefix also. Okay, there is a root word, absolutely, and there is a suffix as well apart from the ane suffix. Okay, so let's start from the root word then. 1, 2, 3, 3 carbon atom chain, so meth eth prop. Now I know there is a prefix, that's why I am writing props p small itself. Then moving to the suffix, again carbon carbon single bond, so ane. And now since OH group is present, so I would just replace this E with what? I would replace this E with the position and the suffix of the functional group. So position is 1 of the OH, right? Suffix is OL, and in the same way I would write the prefix then. The root word and suffix is done. Now prefix is the alkyl group, and before alkyl group it's position. So position is 2 because it is attached to the second carbon atom. So 2 methyl. So 2 methyl propane 1 all. Okay, this would be the name of the organic compound. Now it's time to see the, firstly now we have studied how to write the name by looking at the structure. Okay, now we are going to do the vice versa thing. We are going to see the name, okay, and then we are going to write the structure now. So there are simple 4 steps which you have to follow, and then by looking at the name you can write the structure of the organic compound. Okay, interesting. So first step is to write the carbon skeleton from the root word. Okay, so now I know the root word is this, pent. So I would write the carbon skeleton 1, 2, 3, 4, 5, and I would just join them with the carbon single bonds. This is the carbon skeleton. Locate the functional group if present. So if functional group is present, I would locate it. So I know this double bond is also considered as functional group, and if it is there, there is ene suffix, right? So yes, there is a functional group. Okay, now I would locate it, means I would just write the position of the functional group, or I would just denote the position of the functional group which is given to me. So they are saying the functional group is attached to the second carbon atom. Okay, so second carbon atom. If now I would consider from this side, if I would number from this side, okay, now you can number from this side, that side, no issues. But once you start numbering from a particular side, you just stick to that numbering. So 1, 2, 3, 4, 5, right? So now ene, double bond is to the second carbon atom. So this is first, second carbon atom. Okay, the double bond is to the second one. This means that it is between second and third then. Okay, 1, 2, because if it position was first carbon atom, then it would be between first and the second. Okay, we take the smaller number. Okay, and we take the smaller number as the position. Okay, smaller number for the carbon atom as the position. So second means it is between second and third, not between first and second. Okay, because if it is between first and second, the position would have been 1. Okay, clear with this? Now moving ahead, locate substituents, alkyl or halide groups if present. So yes, there is an alkyl group. So I have deliberately taken an example which includes all the steps. So yes, there is an alkyl group. So I would locate this substituent. Okay, now what's its location? 4. So it's located to the 4th carbon atom. So it is attached to the 4th carbon atom. So this is the 4th carbon atom. So I have located 4, and then the substituent is alkyl group, which is methyl group. So I know methyl is CH3. Okay, now last is satisfy the valencies of the carbon by attaching hydrogen atoms. Now all these carbon atoms valencies should be satisfied, right? We cannot keep them like this hungry. Okay, we need to satisfy their hunger. And how we will satisfy? Just remember, we will satisfy it by attaching the carbon atoms with hydrogen atoms. Okay, so here the carbon is only forming 1 covalent bond. We know tetravalency of carbon atom, 4 covalent bonds should be there. So rest 3 covalent bonds it would form with the hydrogen. Okay, so I would just write CH3 then. Okay, simply because it would form the covalent bonds like this. Okay, so it is CH3, right? Then 1, 2, 3 covalent bonds, one more is required, so H. Okay, or else I can write here H also. Okay, CH also. Okay, then 1, 2 and 3, one more is required, so H. Then 1, 2 and 3, so I am writing it here itself, H. Okay, 4, right, for this carbon, and then for this carbon it's only 1 covalent bond, so more 3 bonds are required, so CH3. Okay, so this is our structure for 4-methyl pent-2-ene. See, 4-methyl 5 carbon atom compound pent-2-ene. Okay, so now we are done with the IUPAC nomenclature thing. Okay, now let's see the next topic, which is simple, very simple, homologous series. Okay, now what is this homologous series? So it's simply, this series is simply a group of organic compounds, okay, which are having similar structure and similar chemical properties. Okay, and these group of organic compounds, okay, they are having the members, okay, members of organic compounds, right, having similar structure and similar chemical properties, and these members of the group, okay, differ from each other, okay, by methylene group. Okay, clear with this point? So how they are differing from each other by methylene group, I will tell you just right now with the help of these examples. Okay, so you can see here the examples: alkanes, alkenes, and alkynes. Okay, so alkanes, entirely the alkanes, these group of organic compounds is a homologous series. Okay, this means that alkenes is a homologous series, alkynes is a homologous series. Now how is it? Let's try and write it down. Okay, so let's write the homologous series of alkenes, alkenes, and then alkynes. Okay, now we know how to write the homologous series. We know the alkenes, and alkynes general formula. Okay, so general formula is for alkenes is CnH2n plus 2, alkenes is CnH2n, and alkynes is CnH2n minus 2. Okay, so once we would figure out the alkanes general formula, it's very easy to write the alkenes and alkynes, not general formula, the organic compounds, okay, in the series. So first one would be, in this case, first one is methane, CH4, you put 1 here, so C1, H2 into 1 is 2, right? So 2 plus 2 is 4, so C1H4, right? In the same way, now C2, now you need to remember one thing, you need to double the number of carbon atoms and then add 2, okay? Double, because it's multiplied by 2. So 2's double is 4 plus 2, 6, C2H6. Same way, C3, 3's double is 6 plus 2, 8, C3H8. C4, 4's double is 8 plus 2, 10, C4H10. C5, 10 plus 2, 12. In this way, okay. So this is the homologous series, and it would run along C6, C7, C8, C9, C10 like this, okay. Now it's very easy to write the alkenes now, corresponding alkenes. How? You need to, what you need to do is simply you need to just make the double of the number of the carbon atoms, just make the double of it, you would get the number of hydrogen atoms. No need to add 2 in it. So see, CnH2n is actually alkenes, right? So but the first member of this alkenes is, like we know now, the carbon, one carbon is present, okay, its structure is like this. So if I would write the IUPAC name of this compound, it's the only carbon, no need to select longest chain and all those entire things. It's only carbon, 1, right? So 1 carbon atoms, root word is meth, and in this carbon, okay, it is, okay, no need to see the single bond as well, because it is the only carbon. Its name is methane, okay, IUPAC name is methane, okay. Now in the same way, you can just see the name of this C2H6, okay. So here 2 carbon atoms, okay, here 3 hydrogen, here 3 hydrogens, okay. So longest carbon chain, this is the longest carbon chain, then numbering the chain 1, 2, okay. Now nothing is present else, so nothing else is there here, so simply 2 carbon atoms means root word is eth, carbon single bond means ane, right? So in this way you can write the names. I'm just writing the names directly, okay. Now, okay, you can just figure out these names on your own as well now. So methane, ethane, okay. This simply CH4 is called as methane, you just remember in this way, no need to go into the details how to find the name according to the IUPAC nomenclature. It is methane. First member of the alkene is methane, then second ethane you can find out, third is propane, you can find out from the rules, fourth butane, fifth pentane. So all these you can find out from the rules as well, okay. Now in case of alkenes, now I would just write C1 H2 into 1 means H2, CH2, but CH2 is not an organic compound, see, because carbon's tetravalency is not followed, not satisfied, so it's not an organic compound. So our CH2, okay, when we take 1 as N, so it is not giving us the alkene, okay. So our first member of the alkene is not CH2 then. Okay, it would come when we would take N is equals to 2, right? So C2, okay, it is here C2, okay, and then twice of 2. So 2 to the 4, H4. So this is the first member of the alkene. Okay, now its name is eth. Okay, same way 2 carbon atoms, but yes, you would just add ene then. Okay, so ethene. Okay, and if you wish to write the name as per the IUPAC, okay, you can just write the structure of this C2H4 as well. From the structure as well, you can just get to know that this is ethene. Okay, but no need to go into that much details. You just relate this with the alkanes. So this is the formula for second carbon alkene. So eth and ene, ethene. In the same way, okay, C3, only the twice, H6, right? The twice of hydrogen, the twice of number of carbon atom is hydrogen, right? 2 into N. So I have just made it twice. C3H6, C4H8, C5H10. Okay, names would be correspondingly, since it's propane. So this would be propene, butene, pentene. Okay. Now coming to the alkynes. So here also 1, by taking N as 1, we won't get the first member of the alkynes. Okay, why? Because see here, C1 H2 into 1 is 2, correct, and 2 minus 2 is 0. So C1H0. Now this is not a compound. Okay, this is simply one carbon atom, okay, which we are getting from the formula. So 1 is not giving us the first member, so we would try with the 2. So C2, and then H2 into 2, 4, 4 minus 2 is 2, so C2H2. Okay, so here C2H2, this is the first member of the alkyne. Okay, now its name is same way, 2 carbon atoms, so eth would be the root word, and then since it is an alkyne, so yne, ethyne, its name is ethyne. Clear? In the same way, you can just, what you can do is, now you can use the alkene formula to write the alkynes formula. Okay, so see here, CnH2n. Okay, we are just subtracting the whatever 2n is coming, we are just subtracting it with 2. Okay, and we are getting alkyne. So Cn is same. Okay, so C3 subtracting H2n by 2. So this is H6, right? So this is 2n. 6 is 2n. We are subtracting it with 2 simply. So we would get H for the alkynes. So 6 minus 2 is 4. So C3H4. In the same way, C4H8, C4H6. I am just subtracting 2 from this formula for hydrogen. C5H10, C5H8. Okay. Then ethyne, same way, propyne because alkyne, butyne, pentyne. Okay. So this is the homologous series for alkenes, alkynes and alkanes. Okay, we need to study this, how we can figure out the homologous series just by remembering a simple general formula, and that's it. Okay, the names also I have told you how to correlate the names. Okay, very simple. Now you can figure out that the first member of alkene is methane, first member of alkene is ethene, and the first member of alkyne is ethyne, and this only we are going to study in the next part. Okay, in the next part, after basics, we are going to study about methane, we are going to study about ethane, ethene and ethyne. Okay, in slightly much more detail. Now let's see the characteristics of homologous series. Okay, so there are 5 characteristics, very simple characteristics. See here. Okay, now we would understand how the difference between the successive members is by CH2 group. Okay, just we have seen here, right? The homologous series are the group of organic compounds having similar structure and similar chemical properties, right? Okay, in which the members of the series differ by CH2 group, right? So how they are differing by CH2 group, I will tell you here. Okay, see, this methane and ethane, they are differing by CH2 group, because when I would add CH2, I would get ethane's molecular formula, C2H4 plus 2, 6, C. Okay, if I would add CH2 here in ethane's molecular formula, I would get propane. Okay, see, C3H8. Okay, same way if I would add methylene group in propane, so C4H10. Okay, so that's why they are differing from each other. The successive members are differing from each other by a methylene group. Okay, if I would minus C4H10, if I would take C4H10, I would subtract CH2 group, I would get C3H8. So they are differing from each other by methylene group. Very simple, right? So this is the characteristic. Successive members differ by CH2 group, and now here, and by molecular mass of 14 atomic mass units. This is related to this only. See, CH2 group's molecular mass is 1 carbon atom, 12 AMUs, okay, and then 2 hydrogen atoms plus 1 plus 1. Okay, so it is 14. So 14 atomic mass units. Clear? And now this thing we have already studied. Okay, the atomic mass of carbon is 12, the hydrogen is 1. I have told you to remember this thing, okay, when we were studying the stoichiometry chapter, okay, chapter number 5 and all those things. Now, first is all members of homologous series have same general formula. We have just now seen alkane, same general formula. All the members of the homologous series. These are the members of the homologous series. They are having same general formula. Members of the homologous series having same general formula, right? Very easy. First one. Second one is done. Then members of homologous series have similar chemical properties. Okay. Now, what does this mean? Okay. These members, methane, ethane, propane, butane, they have similar chemical properties, which means they show similar chemical reactions. Okay, the reaction shown by methane is also shown by ethane, is also shown by propane, is also shown by butane, is also shown by pentane. Okay, clear with this? That is similar chemical reactions. And all the members of homologous series, okay, can be prepared. This is also very interesting. Can be prepared by the same general method of preparation. Okay, so if I'm having a method of preparation, okay, for methane, okay, general method of, if I'm having a method of preparation for methane, then that method can also be used to prepare ethane. That method can also be used to prepare propane. That method can also be used to prepare butane. Okay, so that's the meaning of this line. All the members of the homologous series, okay, these are the members of the homologous series, can be prepared by the same general method of preparation. Okay, now the method of preparation for methane and ethane we are going to study in detail when we are going to study that part. Okay, the preparation of methane and ethane. So that time also you can just correlate it that yes, the method for preparing methane is same as that of the ethane as well. Okay, there are some exceptions to this, but still, it's the most common thing is most of the time we would observe that the methods of preparation are same. Okay, the last characteristic of homologous series, the physical properties of the members. Okay, we have seen the members now of alkane, alkene, alkyne. So that were the examples. Okay, like that alcohols are also the homologous series. Okay, alkyl halides are also the homologous series. Okay, aldehydes are also the homologous series. Carboxylic acids are also homologous series, but no need to go into that much complexity. Okay, for simplicity in your syllabus they have given just the examples to be explained, which are alkene, alkene, alkynes. So physical properties of members, okay, of the homologous series change gradually, okay, as the molecular mass increases. Okay, so for this we would see an example, then you would understand, okay, how the physical properties of the members are changing. So the boiling point, melting point, density, these are the physical properties, okay, of the successive members of the homologous series increases with the increase in the molecular mass. Okay, how? Let's see this table and understand. So these are the successive members of the homologous series: methane, ethane, propane, butane, pentane, right? We have just now seen. Their boiling points are written here. Okay, now you can observe when we are moving, okay, like this in the homologous series. Okay, when we are moving through the successive members of the homologous series, okay, the boiling point here you can see, okay, boiling point of the successive members of the homologous series when we are moving down, okay, in the successive manner in the homologous series. Okay, what is happening? It is increasing with the increase in the molecular mass. See, it is increasing from -161 to -88, -88 to -44, -44 to 0, 0 to 36.2. Okay, now I no need to tell you like this thing. Okay, you would say, sir, 161, 88, 44, it's decreasing. Just please apply the number line concept here. Okay, the negative number, okay, here it is -161, then in the number line it would be -88, then it would be -44.5, right? Then it is 0, and then it is becoming positive. So what is happening? The boiling point is actually increasing, right? It is increasing, it is becoming more and more positive, correct? Okay, this means when we move like this, okay, 36.2, then 0, then this, -44, -88, -161, this is decreasing, this is increasing, right? Very simple logic. Now you can observe this is increasing with the increase in the molecular mass. See, increases with the increase in the molecular mass. So here also the molecular mass is also increasing. This is increasing with increase in the molecular mass. See, 16 to 30, 30 to 44, 44 to 58, 58 to 72. Okay. Is it very clear? Okay, so now after studying the homologous series, let's come back to the functional group characteristics. Okay, characteristics of functional group. Now you could understand the characteristics of functional groups in a better manner. Okay, so first is the chemical properties of the compounds containing the same functional group. Okay, same functional group. Like suppose alkene. Okay, these are the compounds containing double bond, same functional group, are similar. Okay, so chemical properties means chemical reactions shown by them. Okay, now you can observe, okay, or we will study in the later topic that alkenes. Now I have taken example for the compounds containing same functional group as alkenes. Okay, suppose alkenes, compounds containing same functional group, for example alkenes, because they are all having double bond, same functional group. Okay, now what is said that the chemical properties of such compounds are similar, which means chemical reactions of the alkenes are similar. Chemical reactions shown by alkenes are similar, and yes, all the alkenes show similar chemical reactions. Okay, the addition reaction which is shown by the alkenes, okay, it is similar for all the alkenes. So we will learn that thing in detail, don't worry about it. Just I need to tell you that this thing we are going to learn it in very much detail. Okay, now here the compounds having same functional group are identified using same type of tests. That's the reason. Okay, since they show same chemical properties, okay, which means same chemical reactions, so I know any alkene would give me this chemical reaction. Okay, because alkenes are showing addition reaction. Okay, suppose for example alkenes are showing addition reactions. Now I know any of the alkene would show addition reaction. So I would take a particular addition reaction, a same type of test, right? Same type of test it would be a particular addition reaction I would take up, and then I would try on the compounds. If those addition tests are positive, then that means that our compound is alkene. Okay, right? Now let's move ahead. Physical and chemical properties of the compounds of different functional groups. Okay, suppose for example alkane and alkene. So these are the compounds with a different functional group, and their physical and chemical properties are different. Obviously they would be different because functional groups, okay, affect the physical and chemical properties as well. Okay, most of the time functional groups affect chemical properties, but yes, they do affect physical properties as well. Okay, we have seen this thing initially only, right? The alkyl groups mainly determines the physical properties, but the functional groups, okay, they mostly determine the chemical properties. Okay, but sometimes also functional groups also largely affect the physical properties as well. You can learn about those things in case of alcohols as well. Okay, so because of the alcohol group, OH group, the alcohols are soluble in water. Okay, so that is the physical property, solubility, but because of the functional group it is affected. Okay, normal hydrocarbon chain would not be soluble, but alcohols are soluble. Okay, no need to go into the details. You would learn it in the higher classes when you would study alcohols, because in your syllabus alcohol has been deducted. Okay, now there exists a homologous series of compounds containing a particular type of functional group. Now this thing is correlated to the thing which we have studied in the homologous series. Okay, so they are saying, okay, there exist a homologous series of compounds, okay, containing a particular type of functional group. So we have seen alkenes, okay, their alkenes are homologous series, right? And they are having particular type of functional group as well, which is carbon-carbon double bond, right? Okay, now moving to the last topic of the basics, which is isomerism, and very interesting topic. Okay, so what is isomerism? It is actually a phenomena, okay, and in this phenomena you would find, okay, suppose there is a compound A, compound B and compound C. So you would find two or more compounds, okay, they are existing, and how are these two or more compounds which are existing, okay, in this phenomena? These two or more compounds are having same molecular formula, okay, exactly the same molecular formula, but they have different properties. Okay, this is where the game is changing. Okay, so the phenomena of existence of two or more compounds, okay, phenomena of existence of two or more compounds having same molecular formula but different, okay, having same molecular formula but different properties. Clear? So these are all having same molecular formulas, but their properties are different. Okay, and this phenomena is called as isomerism. Okay, clear? Now, what are isomers then? These compounds, okay, such compounds which are having same molecular formula. Okay, compounds having same molecular formula, but different properties, okay, are called as isomers. Okay, so simply isomerism is nothing but, to tell you in a simple one line, isomerism is simply the phenomena of existence of isomers. Okay, because if you would correlate this part, okay, this part, I would just denote it with some other color. This part, if you would see and try to relate it with the isomers definition, you would see the same thing. Compounds having same molecular formula but different properties. Compounds having same molecular formula but different properties. Okay, so the phenomena of existence of isomers is simply isomerism. Okay, now it would be easy for you to understand. Isomers are simply those compounds which are having same molecular formula but different properties. It's very interesting, right? Because by looking at the molecular formula, you would feel that, oh, there is only one compound, right? But no, there are more than one compounds which are having the same molecular formula. Okay, but they are showing different properties as well. But because we would expect that since they are having same molecular formula, they should show same properties, but it is not happening. They are showing different properties, and this phenomena is isomerism. Now, the isomers differ in physical properties, or they differ in chemical properties, or they differ in both physical as well as chemical properties. Okay, so it depends. For example, let's take an example and let's try to understand this thing. See, butane and isobutane. Okay, so these are the two different compounds. Okay, these are the two compounds. Okay, two different compounds, but they are having same molecular formula. Okay, if I would see the structure of these two, they are different, but they are having same molecular formula. Okay, and such compounds, these two compounds which are having same molecular formula, okay, they are showing different properties. You can observe butane's melting point is 0 degrees Celsius, while isobutane's melting point is minus 12 degrees Celsius. Oh, okay. So though both of them are having same molecular formula, though they are having same molecular formula, okay, their properties are different. Okay, having same molecular formula but different properties. So therefore they are isomers. Okay. Now let's see the types of isomerism. Okay. So here isomerism is broadly classified into two types. First of all, first is structural, and the second type is stereo isomerism. Structural isomerism and stereo isomerism. Okay, the name is interesting, right? Stereo, something related to sound and all those things. Okay, but we are not going to study the stereo isomerism right now. Okay, you would study in your higher grades. We are going to focus on the structural isomerism here, and that too, in structural isomerism there are 4 different types of structural isomerism. Okay, chain isomerism, position isomerism, there is one which is called as metamerism, and there is also another one which is called as functional isomerism. Okay, but we are going to only study this two, chain and position only. Okay, so don't worry. Okay, just this two, and then our isomerism part is also done. Okay friends, so now let's see the two types of structural isomerism one by one. So first is chain isomerism. Okay, now it's simply the same like that. The meaning of the chain isomerism is also very simple. Okay, it is simply the phenomena of existence of two or more compounds. Okay, the same like that of the definition of isomerism, but here the two or more compounds are like the same thing. They are having same molecular formula, but they have different carbon skeletons. Okay, now carbon skeleton we all know. Okay, so let's see an example and then we would understand. Okay, and yes, this is the isomerism, chain isomerism. What is chain isomerism actually? The simple definition would be chain isomerism is simply the phenomena of existence of chain isomers, right? And what are the chain isomers? You just correlate this part, okay, this part with the chain isomers. Okay, then you would find the phenomena of existence of chain isomers is the definition for, or it is what actually the meaning of chain isomerism. Okay, two or more compounds having same molecular formula but different carbon skeletons. C, compounds having same molecular formula but different carbon skeletons. These are chain isomers. Okay, so phenomenon of existence of chain isomers is chain isomerism. Now, let's see an example, then you would be able to understand. So, butane and isobutane, this is the first example which we have already seen. Okay, but now I would draw the structures to show that they are chain isomers because they do have the same molecular formula but different carbon skeletons. Okay, so how the carbon skeleton is there for butane? See, simply 1, 2, 3, 4. There are 4 carbon atoms linked in the straight chain. Okay, and now we know it is an alkane. So simply what we would do is simply we would satisfy the carbon's tetravalency by attaching hydrogen atoms to it. Okay, so 1 covalent bond, so rest 3 covalent bonds, 4. That's it. 1, 2, 3, 4 covalent bonds, 1, 2, 3, 4 covalent bonds, and then 1, 2, 3, 4 covalent bonds. Okay, so this is butane. Okay, this is how the butane looks like. And isobutane is like this: 1, 2, 3. Okay, the carbon skeleton for this was simply the straight carbon chain. Okay, but here in this 3 carbon atoms are in the straight chain like this. Okay, and there is one branch on the second carbon atom. Okay, so 1, 2, 3, 4 carbon atoms totally, they are making butane. But since here you can see on the second carbon there is a carbon chain. Okay, so here it is having some different carbon chain, right, carbon skeleton. Okay, and this is isobutane then. Okay, so you can see here I will just satisfy the valencies. Okay, so 3, 4, 3, 4, 1, 2, 3, 4, and then 1, 2, 3, 4. Okay, so this is isobutane. Understood the structures? Okay, isomers, okay, of butane. These are the 2 isomers of butane. So in exams also they can ask you draw the isomers of butane. So isomers of butane are these 2. Okay, one's name is butane itself, second isomers of the butane's name is isobutane. Okay, in the same way, let's see another example of structural isomerism, that is pentanes, isomers of pentane. So isomers of pentane are pentane, isopentane, neopentane. Okay, now we know pentane's molecular formula would be C5H10 because pentane is the 5 carbon atom alkane. Okay, putting the 5 N as 5 in the general formula of alkanes, you would get pentane's molecular formula. Okay, CnH2n plus 2. So C5 H25 is 10 plus 2 12. So C5H12. Okay, C5 25 is 10 plus 2 12. So C5H12 in this way. So now the isomers of pentane, how we can write them? Okay, in this way, in this manner. So first pentane, simply pentane. So 1, 2, 3, 4, 5. All the 5 carbon atoms are in the straight chain like this. Okay. The isopentane's carbon skeleton, okay, is slightly different. How? 1, 2, 3, 4 are in the straight chain, and on the second carbon there is a carbon branch. Okay, there is one carbon attached to the second carbon. Okay, as a branch. And for the neopentane, it's slightly very much interesting. 1, 2, and 3 in the straight line, and 1 above the second and 1 below the second carbon atom. Okay, in this way they are linked. Now what is remaining is simply just satisfying the valencies of the carbon and our job is done. So now it's a very simple task. Okay, you can just do it on your own as well. CH3, 4, 4, 4, 4, and then 3 plus 1, 4. Okay, in this way here 3, 4, 3, 4, 1, 2, 3, 4. Okay, so these 3 are done. 1, 2, 3, 4, 1, 2, 3, 4. Okay, and here also satisfying the valencies 3, 4, 3, 4, 3, 4, 3, 4. Okay, and this is already satisfied 1, 2, 3, 4. Okay, so these are the structures for isomers of pentane. So in exam they may ask you, okay, this question has been asked, okay, not about the pentane but about the butane as well. Okay, and they may, and maybe the pentane's isomers are also asked in your exams, but you just be prepared to write the structures of both the isomers of butane as well as isomers of pentane. Okay, the names I also have told you what are the names. Okay friends, so now let's see the next type of structural isomerism, which is position isomerism. Okay, so simply it's position isomerism is also a phenomenon of existence of 2 or more compounds having same molecular formula. Okay, up to this it's exactly the same like that of the chain isomerism, but here the difference is these 2 or more compounds have same molecular formula but different positions of the functional group. Okay, but different position of the functional group. Clear? So now we can simply say that position isomerism is a phenomenon of existence of position isomers. Okay, because position isomers, okay, are simply the compounds having same molecular formula but different position of the functional group. Okay, So now let's understand this thing, okay, with the help of an example, then it would be clear to you. So these are the two compounds which are having same molecular formula. You can see butane 1-ol, butane 2-ol. If I write the molecular formula of this, okay, I would get butane C4, okay, and then for in place of one hydrogen of the butane, OH group is been taking place, okay. So for butane, it's simply C4H10, right, because it is an alkene, okay, CnH2n plus 2. Then in this, in place of one hydrogen, what we are having, a OH group is having, okay. So that OH group is also having a hydrogen. That's why hydrogen's number won't change, just addition of one oxygen would take place, okay. So one hydrogen is removed, but one hydrogen is also there present, okay. So that would neutralize it, and then oxygen. So this is C4H10O. This is the molecular formula of both these, butane 1-ol, butane 2-ol. But when we see this compound, okay, this compound is having, though it is having same molecular formula, okay, compounds having same molecular formula, but it is having different positions of the functional group, okay, but different position of functional group. Now how the position of functional group is different, let me tell you, okay. So here in butane 1-ol, this is the structure, okay, you can write it on your own as well, CH3, CH2, CH2, okay. So here the OH group is attached to the first carbon of the carbon skeleton, okay, and here in butane 2-ol, you can see 1, 2, 3, 4, okay, the OH group is attached to the second carbon of the carbon skeleton, okay, longest carbon chain, CH3, CH34, CH2, and then CH3, okay. So this is the only change between these two compounds, and when you would tally it, C1, 2, 3, 4, right, C4, and then H, 3 plus 1, 4, 6, 9, and then 10. So C4H10O, right, C4H10O, correct. So these are the two isomers, okay, and which isomers? Position isomers, because they are having same molecular formula but different positions of the functional group, okay. The same way, okay, here in case of but1 and but2 also, but1 1, 2, 3, 4, but2 1, 2, 3, 4, carbon skeleton is but simply, but but1. So between first and second carbon there is a triple bond, and since it is but2, this means that, okay, the lowest number is 2, okay, and that is the position, but now it is also between the another carbon atom which is having highest number, okay. So but2, right, another carbon atom which is having highest number. So it is between 2 and 3 then, okay, since its position is 2, but this means that it is also the another carbon atom between which the triple bond is there, which is having higher number, okay. So 2 and 3, here it is, the position is 1, but it is between the carbon atom which is having higher position than the 1, okay, or higher number than the 1, so 1 and 2. So now 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, okay. And in the same way, CH3, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 3, 4. So this is but1, this is but2. Clear? Now what's the difference in them? They are having same molecular formulas, 1, 2, 3, 4, okay. So C4, right, and then hydrogen 1, 2, 3, and then 3, 6, H6. So C4H6, so 1, 2, 3, 4, C4, 3 plus 3, 6, C4H6. Both are having same molecular formula, but different positions of the functional group, triple bond. Very simple. Now, let's see some questions based on the topics, based on the concepts which we have studied so far. Okay, so we have completed all the basics of the organic chemistry which we need to study according to your syllabus. Okay, so first is this question, and you can observe the year in which the question is asked in your ICSE exams. It is here. Okay, it is written here. Now, question is complete the following table which relates to the homologous series of hydrocarbons. Okay, now the table, in this table they are given general formulas. Now general formula is CnH2n minus 2. Now we know what they have asked, IUPAC name of the homologous series. So CnH2n minus 2 general formula is of alkyne, right? So IUPAC name is alkyne of the homologous series. Same way CnH2n plus 2, it's alkane general formula, and IUPAC name of the homologous series would be then alkene, because we know alkane is also homologous series. Okay, Alkynes are also homologous series. Okay, we have studied. Then characteristic bond type. In this alkyne, what is the characteristic bond type? Carbon-carbon triple bond. You can just write in this way. Okay, triple bond, carbon-carbon triple bond. You can write carbon-carbon triple bond. Okay, and here carbon-carbon. In case of alkanes, it is carbon-carbon single bond. Okay, and here IUPAC name of the first member of the series. IUPAC name, okay, don't get misleaded. So for alkyne, we have seen the first member is ethine, right? You can go back in the slides, you can check C2H2, ethine. So IUPAC name, ethine. And here in case of alkane, the IUPAC name of the first member of the series is methane. I have told you, right? Okay, you can just go back into the video and check it out, where we have seen homologous series, the examples of homologous series. You would get answers of all these things. Okay, this is very basic one, but answers of these two questions you would get there. Okay, right. So now let's see the next questions. Asked in 2019, what is the special feature of the structure of ethine? Okay, so here we know that ethine's structure, it is an alkyne, right? Ethine, just now we have seen. An alkyne's special feature is their carbon-carbon triple bond. Okay, so you can just write in words, carbon-carbon triple bond. Name the saturated hydrocarbon. Saturated hydrocarbon. Okay, so hydrocarbons are of two types, open chain, closed chain, and in the open chain we have seen saturated and unsaturated. Okay, so hydrocarbons, open chain, closed chain, and in open chain we have seen saturated and unsaturated. And in saturated there is only alkanes, right? So they are asking about alkanes. So name the saturated hydrocarbon means they are asking name the alkane containing 2 carbon atoms. So alkane containing 2 carbon atoms, what is the name of that alkane? Okay, we know it is C2H6. Okay, if I would just write if I would put the N is equals to 2 in general formula, I would get C2H6, and I know this is ethane. Okay, ethane's molecular formula. Okay, so IUPAC name is ethane. Answer is ethane. Okay, give the structural formula for acetic acid. Now see, acetic acid, it's not in our syllabus, okay, right now here, but yes, acetic acid we have studied, okay, when we were seeing the trivial names, right? Remembering, we have seen the trivial names and IUPAC names. Okay, and before IUPAC names we have started with the trivial names, and I have introduced you with the trivial names that they are based on the source of the organic compounds. So methane and acetic acid, I have told you. So acetic acid is obtained from the vinegar, which is called as acetum in Latin. So that's from that acetum the name is acetic acid. So formula for acetic acid, if you would have looked it carefully, if you would have studied it, it is CH3COOH. As such, okay, this belongs to the carboxylic acid part. Okay, but still you can also answer it from the existing syllabus. Okay, now let's see the next question. Draw the structural formula for each of the following. So see, we have studied how to draw the structural formula from the name itself. Okay, what are the 4 steps? Very simple. I will just list it down again. We have to just write the carbon skeleton first, okay, by looking at the root word. Then second is we have to locate the functional groups. Third is we have to locate the substituents or alkyl groups. Okay, here substituent means alkyl groups. Okay, because we are like concerned with alkyl groups only at this level. And then lastly we have to satisfy the valency of carbon atoms. Okay, so we know tetravalent carbon atoms are tetravalent. It forms 4 covalent bonds. We need to just make sure that carbon is forming 4 covalent bonds. For that we have to attach the carbon with the hydrogen in order to complete the 4 covalent bonds. Okay, so now first is 2,2 dimethyl pentane. Okay, so from the root word, first we will take the carbon skeleton. Root word is pent here. Carbon skeleton 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Then we would move on to the location of functional groups. Now here functional group, there is no functional group as such, because here we can see ANE suffix is there. So it is simple alkane. Okay, so carbon-carbon single bonds is there. That's it. So we are done with the root word and the suffix. Okay, we are done with the carbon skeleton and the location of functional group. Then next is location of substituent, which is alkyl groups. Here you can see this is the alkyl group. See, dimethyl. Before the root word, where there is a prefix, and this prefix is having an alkyl group name. Okay, methyl is the alkyl group name, and di means there are 2 methyl groups. Okay, so 2 CH3 groups first of all, and their position is given as 2, 2. This means that it is attached to the second carbon atom itself. Okay, because we have studied when the alkyl groups are attached to the same carbon atom, then we repeat the numeral as well. Okay, so it is attached to the second carbon atom. Both of them are attached to the second carbon atom. So if I would number this carbon chain from either of the any sides, it's fine, it's all okay. Okay, because it's simply a carbon chain. Okay, and now this is the second carbon atom. Then if I would number it from here, so on second carbon atom there are 2 methyl groups. Okay, clear? That's it. Now what we have to do is fourth step, satisfy the valency of the carbon atoms. So here simply, okay, I would just make sure that the carbon atom forms 4 covalent bonds. If it is not forming 4 covalent bonds, I would make it form 4 covalent bonds. How? By making it form the bonds with the hydrogen, making remaining bonds to be formed with the hydrogen. Okay, so CH3. Okay, so 3 bonds with hydrogen, 1 with carbon, so 4, right? So 1 2 3 4 4 bonds, 1 2 3 4. Okay, and here see 1 2 3 4. So this carbon is already satisfied, very happy. 1 2 3 4. So this is our 2, 2 dimethyl pentanes structure. Okay, 2 methanol. So here in this, simply root word is meth, right? So meth means 1 carbon. That's it. Here of the suffix ane, the e is replaced by ol, right? ane e is replaced by ol. So this means that it was previously an alkane like that. Okay, but since it is 1 carbon atom, then we don't care about it. We know, okay, this is 1 carbon atom, that's it. And simply there is an ol, which means there is an alcohol group attached to the carbon atom. So it would be definitely attached to this only, right? So carbon skeleton is done. Since it is 1 carbon, so 1 carbon written. Location of functional group, there is a functional group, yes, ol means alcohol group is there, but its location would be like that carbon atom itself. And then locating the substituent alkyl group, no substituents case here. Lastly, satisfy the valency of carbon atom. Satisfy the valency, it is forming 1 bond with OH, rest 3 bonds are formed with the hydrogen. So this is methanol. Okay, CH3OH. Okay, it's very basic compound. There is no need to go through these rules as well in order to find out the name of this compound when you get used to the organic chemistry. But now since you are new to organic chemistry, that's fine. You can use these rules and get back to this compound, okay, by looking at its name. So with this, we have reached the end of this video, and I hope you would have enjoyed learning with me. You would have understood all the concepts which we have learned so far in this video. But please do let me know this thing in the comment section, that whether you have enjoyed learning with me, you understood the things, whether you have any doubts. Okay, I'm waiting for your comments. And as you all know, LearnoHub matlab free hai par best hai. So stay tuned. We will see the next part, alkanes, alkenes and alkynes, in the next video. Okay, till then, keep studying. Bye bye and have a great day.